know how to do like 5 of the questions on it, so we won't be due till Monday. Unfortunately, there's not much on there that you'll know how to do unless like you learn from your foldable yourself. Like if you read your flaps, you could figure out how to do the problems if you wanted to, or of course you can wait till tomorrow when I actually teach you. Okay, so I just want to go through this. We're into our section of quadrilaterals. So a quadrilateral is just a figure with 4 sides. So on our little foldable, I just drew these 3 different shapes down here. These are all quadrilaterals. They all have 4 sides. Later I'm going to talk more about these words, but these guys right here, the first and third one, they're called convex, and this one here is concave. Do you see how it caves in? So these 2 are convex, this one's concave. If you look at all the pictures on this page here, these are all convex. None of these cave in. So, and we'll talk more about that later, but I just kind of wanted to explain that since I had you guys draw those on the front of this, that these are all quadrilaterals because they're all 4-sided figures, but this one's concave because it caves in. Okay, and then do you know what the angles add to be in all quadrilaterals? What do all the angles add to be?
180.
360. Like the rectangle and the square, think of it, 90, 90, 90, 90. 360. So no matter what the quadrilateral is, the 4 angles will add to be 360. So I'm just going to write that right here. Angles add to equal 360 degrees. And if that was something you felt like you needed to put on your foldable because you just didn't know or you think you might forget, then you could put that on your foldable. But anytime you have a quadrilateral, the angles inside are going to add to be 360. Okay, so I just kind of want to go through our different shapes. So our first shape here is a parallelogram, and a parallelogram is a quadrilateral because it's got 4 sides, and then both pairs of opposite sides are parallel. And remember, that's what the arrows mean. So these 2 sides are parallel, these 2 sides are parallel. And then the other thing that's special about it is that both pairs of opposite sides are congruent. So the top and the bottom are congruent, and the left side and the right side are congruent. So that's all we know about a parallelogram. Opposite sides are parallel, opposite sides are congruent. That's it. That's all we know about a parallelogram. And then we have others that we're going to learn more about. Okay, so the rhombus. The rhombus, this is the one that you guys learned to call a diamond. I think when you're in elementary school that you guys always call it a diamond. So a rhombus, it's a parallelogram, which means the opposite sides are parallel and the opposite sides are congruent. But what's special about it is it's got 4 congruent sides. So all 4 of these sides are the same. But do you know why a rhombus isn't a square, even though it kind of looks like one?
It doesn't have 90 degrees.
Right. It doesn't have 90-degree angles. So there's no right angles. Not necessarily because it's tilted, but just because they're not 90-degree angles. And, of course, those look like they're 90 degrees because I had to draw that picture, and, well, that's just how it comes out. Well, in Word, like in the drawing program. Okay, then we have a rectangle. This is a parallelogram too, meaning opposite sides are parallel, opposite sides are congruent. And then what's special about it is it's got 4 right angles. So all of your angles are 90 degrees. Okay, next one up is a square. So a square is also a parallelogram, which means opposite sides are parallel, opposite sides are congruent. And then what's special about it is it has 4 congruent sides and 4 right angles. So all 4 sides are equal and all your angles are 90. Okay, then we get into shapes that aren't parallelograms. So a kite. It's a quadrilateral, meaning it has what? 4 sides. Very nice. But it is not a parallelogram. So all that's special about it is that it has 2 pairs of adjacent sides that are congruent, but none of the opposite sides are congruent. So these 2 sides right here, they're adjacent because they're next to each other, so they're congruent. These 2 sides are next to each other, so they're congruent. But your opposite sides, they're not congruent. These opposite sides, they're not congruent. And this right here, you don't have any parallel sides. So it can't possibly be a parallelogram because there's no parallel sides. Okay, next one up is a trapezoid. This is also not a parallelogram. It's a quadrilateral because it's got 4 sides, but it only has 1 pair of parallel sides. So these guys right here, they're your parallel sides. On the foldable, what do we call the parallel sides? Bases. In the trapezoid, your parallel sides, those are your bases, and the sides that aren't parallel, those are the legs. So in a trapezoid, your parallel sides, those are called the bases, and the ones that aren't parallel, those are called the legs. And we'll need to know that more for later. Okay, and then we have a special kind of trapezoid, and that is called an isosceles trapezoid. And so it's a trapezoid where the non-parallel sides are congruent. So these sides here that aren't parallel, they're congruent. And that's what makes something an isosceles trapezoid versus just a plain trapezoid. So like on this one, the opposite sides, they're not congruent, so we just call it a trapezoid. And then this one, the opposite sides that aren't parallel, they are congruent, so this one's an isosceles trapezoid. Okay, just judging by appearance, what do you think we could name these shapes? And I want to name them as many things as possible.
Rectangle.
Okay, rectangle. And we're just judging by appearance, so we really don't know anything for certain. What else does it maybe look like? Of all those words that are on this page, it is a parallelogram, because it definitely looks like opposite sides are parallel and opposite sides are congruent. Does it look like anything else? Does it look like a square?
No.
There's another word that we talked about on this page. Now, a rhombus has to have 4 congruent sides. Does it look like those sides are all the same length? There's another word, quadrilateral. It's a 4-sided figure, right? So it's got to be a quadrilateral. Okay.
I thought you were talking about number 2.
No, I'm still on number 1.
Oh.
I was like, Mason, really? Okay, that's it. That's all it looks like. Of course, I don't know for certain without all the markings there.
Looks like a brick.
Okay, what about the next one? What does that look like to you?
Square.
Okay, kind of looks like a rhombus.
There you go.
It might be a square. I don't know if those angles are 90 degrees or not, and we're just judging by appearance. So it looks like a rhombus because all 4 sides they show us are congruent. It looks like a square.
Parallelogram.
It's definitely a parallelogram because opposite sides are parallel as well as congruent. And something else. It's a quadrilateral. It's got 4 sides. So it's a quadrilateral. Okay, number 3, what do you think? Trapezoid? Not a dinosaur. What else besides a trapezoid? Does it look like an isosceles trapezoid? No, these guys don't look congruent. And what'd you say, Olivia? It is a quadrilateral. Yes, and all of these are convex. Okay, and that's it for number 3. Okay. Let's flip to the next page. And this diagram that's on this next page is on the back of your foldable. And I'm going to have you write something on there tomorrow about this diagram. But this is on the very back of your foldable. And like I said, tomorrow I'll have you write that down that you see there. But we'll worry about that tomorrow. Okay, the way this works is everything is the shape above it. So, for example, all squares are rectangles. Because to be a rectangle, all you have to have are 90-degree angles and opposite sides congruent. Well, in a square, does it have opposite sides congruent and all 90-degree angles? So every single square is a rectangle. Every single square is a rhombus. Because to be a rhombus, you just have to have 4 congruent sides. And all squares have 4 congruent sides. So every square is a rhombus, every square is a rectangle, but it doesn't work the other way. So you can't say every rectangle is a square. Does that make sense? Because not every single rectangle has all 4 sides congruent, right? So you can't say every rectangle is a square, but you can say every square is a rectangle. Now you could say some rectangles are squares, some of your, technically it's supposed to be rhombi are squares, but everything is a shape above it. So all squares are rectangles, all squares are rhombi, all squares are parallelograms, all squares are quadrilaterals. You could say all rectangles are parallelograms, all rectangles are quadrilaterals. All isosceles trapezoids are trapezoids. All isosceles trapezoids are quadrilaterals. And then the way it goes down is some quadrilaterals are trapezoids. Some trapezoids are isosceles trapezoids. Okay, so we're going to try to decide if these are true or false, and we're going to look at the figure above to see. So number one, it says every rectangle is a parallelogram. What do you think? That is true. And that's because parallelogram is above it. So every rectangle is a parallelogram. Okay, number two. If a quadrilateral is a square, then it is a rectangle. If a quadrilateral is a square, then it's a rectangle. That's true because everything's the shape above it. All squares are rectangles. All squares are rhombi. So if a quadrilateral is a square, it will be a rectangle. That's true. Okay, number three. And I put rhombuses here, but it really is supposed to be rhombi. All rhombi are squares.
Yes. True.
This one's false.
All squares are rhombi. That'd be true.
Yeah, all squares are rhombi. Some rhombi are squares. Every shape's the shape above it, but it doesn't work the other way. Okay, number four. It says every rhombus is a parallelogram.
True.
That's true. Okay, I want to see if you can do the 5 through 9, and then we'll just see what you put. I'm a made-up one. It's my I think I'm going to draw sticks song. Ricky, number 5 goes to you. What'd you put?
True.
It is true. All squares are rectangles. Everybody okay with that?
Yeah.
Okay, and that's because rectangles above squares, so that's the way it works. Kim, what about number 6?
False.
That is false. So you can't say every rectangle is a square, but you could say some rectangles are squares. But if every rectangle was a square, then you wouldn't have rectangles anymore. They'd just be squares. Okay, number 7 goes to Valerie.
True.
That is true. Some parallelograms are rectangles. That's true. Brooke, how about 8?
True.
That is true. All parallelograms are quadrilaterals, and that's because quadrilateral is above parallelogram. So all parallelograms are quadrilaterals, but some parallelograms are rectangles, some parallelograms are rhombi, some parallelograms are squares. Okay, and number 9 goes to Cormac.
False.
It is false. If a figure is a parallelogram, then it's a rectangle. It doesn't have to be a rectangle. It could be a square or it could be a rhombus. Okay, so today I really just wanted to focus on the shapes. The next 3 pages, I'll talk about just the parallelogram. So do not lose these notes. We are going to finish these notes tomorrow because tomorrow we're going to focus solely on the parallelogram. Today I just wanted to focus on all shapes in general. So we're going to do just a little bit more on just talking about the shapes on this page. Everybody have one of these? I think I passed out enough. Okay, this revisits the distance formula, which we've done before. Just been a little while since we've done it. It revisits slope.
Yay.
Gross. What? And then it revisits the fact that parallel lines have the same slope, but perpendicular lines, their slopes are negative reciprocals or opposite reciprocals.
That's how it says.
Okay, so what I want to do, and I know that some of these are easier to judge than others just by looking at them, is figure out what shape it is exactly. And really the only way to know exactly is to use the formulas. Now, when I look at this picture, what's this look like?
Height.
Okay, it definitely looks like a kite. And so This one I'm not going to do a whole lot on, but this guy right here, it could be a bunch of things. Maybe it's a parallelogram, maybe it's a rhombus, maybe it's a square, maybe it's a rectangle. So I'm going to find out by doing slope and doing distance formula. So here I go. If I want to find the slope of LM, to get from LM to L to M, I want to count my rise over my run. So to get from L to M, what do we rise and what do we run? We rise 2 and we run 1, 2, 3, right? Okay, so the slope of LM is 2/3. Okay, let's do the slope of, I'll do MN. So the slope from M to N, to get from M to N, I'm going to go down how many? 2 and right how many? 3. Okay, let's look at these two slopes for a second. Are these opposite reciprocals? No, they're just opposites. If these were opposite reciprocals, then these lines would be perpendicular, which means this would be a 90-degree angle. So since these are not opposite reciprocals, it's not a square or a rectangle. So right now, I know this is not a 90-degree angle right here. And the reason it's not a 90-degree angle is these slopes are not opposite reciprocals, which means these lines are not perpendicular. So right now, rectangles out, squares out. Okay, let's just continue on. Finding the slope of NP. What do you do to get from N to P? Down 2? Left 3. So if you go down 2, that's -2. Left 3, that's -3. So what's that? Positive 2/3, because a negative over a negative is a positive. Okay, and then the slope of LP, what would that be? Down 2, right 3. So that one's a -2/3. Once again, you can see that these are not opposite reciprocals, so I don't get a 90-degree angle here either. So the reason you check for slope is to see if you have any 90-degree angles. And if these would have been opposite reciprocals, then I would have had perpendicular lines, which means you'd have 90-degree angles. So no 90-degree angles, so like we said a minute ago, rectangles out, squares out. Okay, so to know if it is a rhombus or just a plain parallelogram, I need to know something about the lengths of the sides. So that's when the distance formula comes in. Okay, so to get from L to M, I'm going to follow this formula from up here, where you subtract your x's, square it, subtract your y's, square it, add them together. So let's look from L to M. How would you write x2 minus x1? 4 minus 1, we close it, square it, plus, and then how would you write y2 minus y1? 5 minus 3, I'm going to close my parentheses and square it. Okay, now I just want to clean this up. So, in the first set of parentheses, what's 4 minus 1? And 3 squared? 9. Then I'm going to recopy my plus. And then what's 5 minus 3? 2. And 2 squared? And what do you get if you add your 9 and 4? Okay, so I get the square root of 13. So I want to see what other sides have a length of the square root of 13. So I'm just going to keep doing it. If all sides have a length of the square root of 13, it's going to be a what? A rhombus. And if they don't all have a length of square root of 13, then it's not going to be a rhombus, but it could be a parallelogram, because a parallelogram has opposite sides being congruent. Okay, so let's find the length of MN. How would you write x2 minus x1? 7 minus 4. You can either go 4 minus 7 or 7 minus 4. It doesn't really matter. And then what about y2 minus y1? 3 minus 5. Okay, I'm going to close it and square it. And then I'm just going to work it out like I did on the last one. So how much is 7 minus 4? 3. 3 squared makes 9. Recopy the plus. And then what's 3 minus 5? And negative 2 squared makes? And what do you get if you add your 9 and 4? Square root of 13. So right now I know LM is congruent to MN. I'm going to give them each a tick mark. They're both the square root of 13, so those two sides are congruent for certain. Okay.
Can you just tell now?
Maybe.
The middle,
But wouldn't we like to do it just again because it's fun?
Why
Why not? I think we should do it one more time. So from N to P, how would you write x2 minus x1? 7 minus 4. Close it, square it. How would you write y2 minus y1? 3 minus what? 3 minus 1. Close it, square it. Okay, and then how much is 7 minus 4? 3. So I get 3 squared, which makes 9. Recopy the plus. How about 3 minus 1? 2. 2 squared makes 4. Looky. He's a square root of 13. So I know the length of NP is congruent to the others. I'm not going to make you do the next one. The next one does come out to be the square root of 13. So what shape is this? This is a rhombus. And why is it not a square again? Because it doesn't have right angles. And the reason it doesn't have right angles is because I didn't have any slopes that are opposite reciprocals, which means you don't have perpendicular lines. And if you don't have perpendicular lines, you can't have 90-degree angles. Okay, well, we could stop now, but we're having all kinds of fun. What I want you to do, you guys are hurting my feelings. What I want you to do is just find me the slope of those 4. No, not for homework. I have a worksheet I'm going to give you, but I'm not making it due till Monday because you only know how to do like the top 5 questions. Well, you could. If you read your foldable or the notes I gave you here, you could learn for yourself. Does anybody watch Jeopardy anymore?
Yes, I'd like to.
Jeopardy?
Mm-hmm.
My grandma watches that.
Exactly.
Okay. I helped myself with some papers, by the way.
Oh, that's fine. I hope you could find some stuff because I think everything's over there somewhere. Okay, Cheyenne, what do you have for the slope of LM? 1. You get 3 over 3, which is 1. Did everybody get that? Do I need to help count? Okay, and then Austin, how about the slope of NP?
I have no idea.
No idea. Okay, you know how slope is rise over run? So I want to know how to get from N to P. And I like to go from left to right, so I'm going to count what I rise and what I run. To get from here to here, can you count how many you go up and then how many you go right? Don't you have the paper right in front of you? So to get from P to N, how many do you go up and how many do you go right? Up 8, love that. And right? 3, because it's just 1, 2, 3. Okay, next one, slope of MN. Christian, what'd you get for that?
I actually was doing the distance formula instead of that.
Oh, well, that's okay. You could do it real quick. To get from M to N, I like to go left to right. You fall how many and run how many? You fall 3, so negative 3, and you run 3 to the right, so positive 3, which makes a what? Negative 1. Very nice. And Harris, how about the slope of LP? Negative 8 over 3. Now, my question for you is, are any of these opposite reciprocals?
No. No.
Yes. No.
Yes. Wait.
Those guys are opposite reciprocals. Yep, because if you flip this over and switch its sign, that's what you get. These guys right here are opposite reciprocals. Can you tell me where your 90-degree angle is then?
On the top.
Yeah, right here at top. LM and MN, those are perpendicular, so there's a 90-degree angle right there. That's the only 90-degree angle we have, and then, of course, it looks like a kite. I wouldn't know that for certain without doing the distance formula, but that's what it looks like. Okay, I have a worksheet I want to give you, and then, like I said, it's not due till Monday. I just want to give it to you now. You can do the first, I guess it's 4 problems. You can do the first 4. Would you mind hitting that side? So right now you could do the first 4, and then tomorrow I'll show you how to do the rest. But like I said, it won't be due until Monday. Yeah, this would be due on Monday. Right now, the only ones I taught you how to do are the first 4. Oh yeah, Tuesday. Because you have a 3-day weekend. Yeah. So it's not due till Tuesday. Yay. So right now you can do 1 through 4 just by looking at that diagram. And then I'll show you how to do the others tomorrow. Because tomorrow we're going to learn all about Mr. Parallelogram.
Why can't it be Mrs.
Yeah, why can't it be a girl? It's because I'm a female teacher, so I just like to refer to them as hims.